Hi there. Let's continue our journey with derivatives. What we have here is f of x equals the square root of e to the x plus 4x, and we wish to find its derivative. And again, since this is a composite function, the chain rule is going to be required. Now remember, with square roots, we usually fare better if it's written as an exponent. And remember that the square root is really a 1/2 power. So we have f of x equals e to the x plus 4x raised to the 1/2 power. So to take the derivative, we just have to remember that the derivative of u to the half is 1/2 u to the negative 1/2, and then times the derivative of the inside. So we're going to keep that in mind when we take this derivative here. So f prime of x is equal to 1/2, keep the inside the same, to the negative 1/2, and then times the derivative of e to the x plus 4x, which I'm going to write in D notation. And now let's simplify. So you have 1/2 e to the x plus 4x to the negative half times, now the derivative of e to the x plus 4x, the derivative of e to the x is e to the x, and the derivative of 4x is 4. So we have that. And now, following the convention, I'm going to write the simpler factor out front with the 1/2. And I'm going to have e to the x plus 4x to the negative half. Now that is an okay answer, but if we desire to have positive exponents in the answer, we do have to keep going. So just remembering what all this means, we have 1/2 times e to the x plus 4. Something to the negative power is 1 over the same something to the positive power. So we have that. And then I can write that as one cohesive fraction. So remember that the e to the x plus 4 here is really over 1. So we really have e to the x plus 4 over 2 times e to the x plus 4x to the half. And if we really desire, we can convert that 1/2 power to a square root. So this final answer is acceptable, as is this one. And if you only care about the answer without writing it in positive exponents, that could also be acceptable as well. Just depends on your instructions when finding derivatives. And there we have it.